Hi everyone, I am Avdesh God. In this video, we will learn about the level of detail expressions in Tableau. We will explore various LODs available in Tableau with their specific use cases. Well, let's get started. The level of detail expressions provides the feasibility to calculate aggregations at a different level than the one available in the view. In the current view, the sum of profit is present at the subcategory level. That is, the profit is aggregated at the subcategory level in this view. But what if we also want to showcase the sum of profits calculated at the overall level? We can create this as a calculated field using the fixed LOD expression. Let us create the same. Fixed LOD function is available under the aggregate functions. It takes up two types of arguments. The arguments before the colon defines the level of detail at which we want to compute the aggregation, and the argument after the colon defines how we want to compute the aggregation. That is, the aggregation can be sum, minimum, average, maximum, count, etc. This calculation starts off with a curly brace and then come the LOD expression. That is, we have used fixed over here. Then we define at what level we want the aggregate to be calculated. If we want the aggregate to be calculated at a lower level, say manufacturer, or at a product level, then we can mention that dimension before the colon. But as we want the sum of profit to be calculated at an overall level, that is, at the complete dataset level, so we have left the first argument as blank over here. Leaving it blank tells Tableau that we want to calculate the aggregate at the complete dataset level. Then we put the colon, and after that, the aggregation is present, that is, the sum of profits. Finally, the calculation is closed with a closing curly parenthesis. Our calculation is valid. Let's hit OK and save this. Let us bring this new calculated field onto the view and turn on the column grand total as well. If we notice the grand total of the sum of profits in the first graph is replicated by the second graph in each row. But what's the benefit of this? In this way, we can use the second graph values as a denominator and the first graph values as numerator to calculate the percentage share of profits for each subcategory. Let us write this in the shelf calculation. But the same could have also been done by the percent of total quick table calculation as well. So how is this different? Let us now convert the first profit into the percent of total by applying the quick table calculation. Now, in order to understand the difference, let us apply the subcategory filter and keep only accessories in the view. If you notice, the percent of total in case of table calculation is showing 100% after the data is filtered. Reason being, the table calculation happens only for the available data in the view. But on the other hand, the calculation using fixed level of detail expression to calculate the denominator is still showing the actual percentage share, that is 14.64%. Reason being, the fixed level of detail expression is calculated first at the overall level and then the dimension filter is being applied. That is, first of all the denominator is being calculated at the dataset level as it was calculated before applying the filter. So that's why it's still showing up 14.64% only. Let us select Appliance and Art as well and hit OK. What will happen if we convert the subcategory filter into a context filter? Let us do that. We'll click on the filter and select Add to Context. Now if you notice, both the fixed level of detail expression and the quick table calculation behaves in the same manner. Reason being, the context filter is applied first and then both fixed level of detail expression and the table calculation is being calculated. And that's why the order of operation is that important in Tableau. In the next video, we will explore the include level of detail expression in Tableau.